Today, we are uncovering one of the most misunderstood topic in Java programming. Yes, one of the most misunderstood topic in Java programming, that is typecasting in Java. It looks simple, it feels harmless, but it hides some of the most dangerous beginner's mistake. So if you ever faced wrong calculations, negative number out of nowhere, or sudden uh, class cast exception, this video will fix that. Let's master the Java typecasting the right way. So welcome back to my YouTube channel Code with Dharamveer. Now, in Java programming, every variable has the data type. Okay, but what happens when you assign integer to double, a double to a integer, or object to a string? That conversion process is called as a typecasting, right? So, and in Java there are exactly two types. So first one is implicit typecasting, that is automatic and safe, and second one is explicit typecasting, manual and risky. So let's break them down. Okay, uh, let's talk about the implicit typecasting. So, implicit typecasting is called as widening, right? So it is called as widening. It happens automatically, right? Now, when you convert uh, a smaller data type into a larger data type, so like if you convert int to a double, byte to a int, okay, so that Java allows this because no data is been lost, right? This is safe typecasting, okay, but don't rely yet. Yes, the danger starts when you go other direction. Yes, you heard it right. Okay, now let's quickly look at this example into the Eclipse. Okay, now I have Eclipse here, so I will just remove this some of the classes, or I'll just make a new package here. Okay, so com dot type dot casting. Okay, so so it will create a new package for me, right? So I'll create a one class here. Okay, type casting. Typecasting. Okay, I'll take a main method as well, and I'll click on finish. Okay, this is my the main method here. Okay, and the typecasting is the class here. Now what we have seen here, we have seen that we are taking a number, that is the integer number, and you are assigning that integer number to a double variable. Okay, so I'll take this here. So I'll take int num equal to 10, right? So I'll use a double variable, double. I take any one of the double variable, I'll take as a num1. Okay, now I'll assign this as the value of num into num1. Okay, so see, I'll print this values here. I'll print this out. Okay, so value of value of num is this one plus num, and same thing, I'll copy paste this and I'll print the value of num1. Okay, so what we have did it here, we have an integer variable as a num, and we have assigned this integer variable to double variable number num1. Now let's quickly run this program. So I'll run this as a Java application. So see, you can see the value of num is 10 because it was a integer variable. Now, integer value. Now we have assigned this integer to a double variable, that is num1. So num1 is what is double variable. So you can see that the widening is happened here, right? So you can see that the value 10 has become as 10.0. It's basically the implicit typecasting, right? So widening. So it's been implicitly converted from int to a double, right? So this is a basic example here. Now let's move on quickly. And this is automatic and there is no loss of the data, right? So now we'll move further. Now, the widening order is basically you have a hierarchy here, right? So, implicit typecasting in Java is also called as a widening. Okay, it happens automatically when you convert a smaller data type into a larger data type, right? Just like if you convert byte to short, short to int to long, long to float, float to double. So it is a basically a hierarchy, widening hierarchy. So it happens automatically. You convert a smaller data type into a larger data type, right? So like this, you are converting into a double, byte to a double. That is also possible, right? Okay, Java allows you this because the node data is being lost here, and this is safe casting. But don't rely yet, right? The danger starts when you go other direction. Yes, when you go other direction. So it's very important to know that you should have a proper typecasting here. Now we'll move here. So we'll move to the next. That one is the uh, explicit typecasting, right? So explicit typecasting is also called as narrowing. Okay, that is, this is a why is basically what is happening here is now we can convert in explicit typecasting in Java. uh, we can convert double to int. So you are doing the reverse here. So you are converting double to int, long to short, int to byte, right? So Java forces you to manually cast this by using the parenthesis, right? So, but here's the hidden danger here, right? Here's the hidden danger. Java does not round the numbers, right? So it's not going to round the numbers, it cuts the decimal part. Okay, so 9.8 as you can see will become 9. Okay, this is silent data loss. Okay, so if you have a variable double variable x equal to 9.8 and you're converting or you're typecasting that into a integer variable, right? So there will be a loss of data. Okay, now let's quickly move on and see this example. Okay, so you have this, I mean, here I'll take the int that is a variable as a, or some variable is a, okay, and I'll give the value as 9.8. Now this is my integer variable, okay, right? Or sorry, I'll give it as a double. I'll take as a double variable a, and that is I'll give the value as 9.8. Now I have an integer variable b, okay. Now I want to convert it to that a double variable into the integer variable. So if I directly do this and semicolon, you can see I'll get the error. So it's saying as a type mismatch cannot convert from double to int. So it's not going to convert the double value into the integer value. So you have to manually typecast it into the integer, right? So I'll typecast it into the integer. I'll use the parenthesis, and parenthesis I'll say int. So now the error has gone here, okay. So now let's quickly print this value, okay. So I'll copy paste this, okay, and this one again copy paste. I'll the print the value of this a is, okay, I'll print, and again I'll print the value of b, okay. I'll comment this part, okay. Now I'll save it, right, and we'll run this program. Right click and run as a Java application. So you can see the value of oh, we made a mistake. That no, yeah, the value of a and the value of b, okay. I'll save it and I'll run it again. Okay, you can see that the value of a is 9.8, right? That's no problem. It was already a double value. Now you have converted the a value to a integer type value, that is double value to the integer value, right? So you can see that there's a loss of precision or loss of data. 9.8 is being lost, so it's not been rounded, right? So you are have yeah, the data is being lost here. So it's manually you are typecasting, and that is basically explicit typecasting, and it's risky, okay, because there is a loss of data, okay. Now let's move on to the next concept, okay. Now there are some hidden overflows, okay, so that you must be knowing it, okay. But you might have been encountered with some of the hidden overflows. This is where the beginners panic, right? Now let's say you have some number that is int big equal to 130, and you are converting it into small, that is a byte, okay. And if you are seeing that output, the output comes out to be minus 126, right? So this is basically, there is Java is wrapping around, okay, because this number, because the range is from minus byte ranges from minus 128 to um, was 127, and your number is 130, that is outside the range, okay. So Java will wrap around. This is the overflow in Java, okay, and that does not give a compile time error. So you'll not get a compile time error. This is a hidden logical bug here, okay. Now let's quickly see this example, okay. So I'll go to Eclipse, I'll comment this part, okay. Now what we need to take int, so you have this int big equal to this one number, that is basically 130, right? 130, and you have byte. You are taking byte as a small, and you are assigning that to a big. Big has been assigned to a small, right? Now you can see I got the error here. Type mismatch, cannot convert from into byte. Okay, now this is basically uh, you are basically getting this error because you are getting you're going out of the range. Okay, so what you need to do is you need to manually, or you need to typecast this thing, and then I'll convert this manually to a byte by using this parenthesis. Okay, so if I print this value, okay, so it's out. Okay, now the value of this value of small is equal to, I'll give as small. Now see, I'll run this program, run as a Java application. So you got this value as minus 126, right? So this is basically, this beginners may get surprised, right? This is because the range of byte is from minus 128 to plus 120, plus 127, right? And the 130 is out of the range. Okay, so Java will wrap around. This is called as overflow in Java, and it does not give the compile time error. It's a logical bug. It's a logical hidden bug. Okay, so you need to keep in mind. Okay, now let's quickly move on to the next concept. Now let's quickly move on to the next concept, that is hidden error, and two, that is integer division. Okay, now this is one of the most common Java mistakes. Even though the result is double, okay, Java performs the integer division first and then convert it into double. Okay, you can see that 5 divided by 2, the output comes out to be 2.0, and that is wrong. Okay, so correct is basically you need to typecast it. Okay, so double result equal to double of 5 divided by 2. Now let's look at this example into the Eclipse. Okay, so I'll just use this. Okay, int, or I'll say double result equal to 5 divided by 2. Okay, so if I print this out result, so if I run this program, I'll get this as 2.0. Okay, so basically this is a wrong answer. Okay, so what I need to do, I need to typecast it to the double. Okay, so I'll use this double. Okay, now if I run this program again, so I'll get the correct answer as 2.5. This happened because the Java was performing first integer division and then it was converting to double. So this is basically a logical bug. Okay, and it doesn't give any kind of a runtime error. Okay, so that you need to keep in mind. Okay, so that's why the typecasting in Java is very critical. Okay, so you need to understand these concepts first. Okay, now let's move on to the next concept here. Basically, the typecasting in Java is about the primitive data types. It applies to object also. So that means you are applying the typecasting to objects also. Okay, so upcasting, that is automatic. Downcasting, you have to explicitly mention that. Okay, but there is a risk of class cast exception. Okay, now if you have some example, say you have a class like animal. Okay, and you are assigning the uh, object of the dog into the animal. Okay, and if that is basically upcasting. Okay, and if you have a dog, okay, instance of dog, and if you are assigning the instance or object of the animal, that is basically a downcasting. Okay, what I mean to say is I'll show you practically. Okay, now basically an eclipse will go here. Okay, we'll create a one class here. Okay, and I'll say as type type casting example. Okay, now basically I'll take a main method here now. Okay, and I'll say finish. Okay, now this is my main method. Now I'll create one class as an animal class as class animal. Okay, in this I'll create one method void sound. Okay, and I'll sys out. I'll say uh, animal make sound. Makes sound. Okay, now this is my animal class, and I'll create again class dog that basically extends animal. Okay, now in this, what I'll take a method as void bark. Okay, and I'll sys out this. I'll copy paste this here as dog barks. I'll make it as dog barks. Okay, now I'll come to my main method. Okay, now I'll create the object of, or I'll create a reference of animal A, and basically animal A is assigned as a reference, is assigned as object of dog. Okay, now I'll call the method as a dot sound. Okay, now this is basically what this is basically uh, upcasting. Okay, this is upcasting. upcasting in Java. Okay, now I'll I'll show you the example of downcasting as well. Downcasting. Okay, so what we need to do, we need to do reverse of this. I have a, I have a reference of dog, I have a reference of dog class D, and I am basically assigning the reference of or object of this animal to dog. Okay, so I'll say semicolon. Now it's giving me error, type mismatch, cannot convert from animal to dog. Okay, so you have to explicitly typecast this one. Okay, so explicitly typecast into a dog. Okay, now the error has gone, you can see. Okay, so now you use this and call the method bark. Okay, right, and basically now we'll run this example. Now let's see what the output comes. See, it's giving me output as animal makes sound, dog barks. Okay, so basically what is happening here is you are basically assigning the reference, you are assigning the object to a reference. Okay, and basically that is being casted here. This is basically the upcasting. Okay, and this is basically a downcasting. Okay, now there might be some runtime error as well. Okay, so you need to keep in mind. Okay, so basically if I'll show you, if I create, okay, so if I create another instance of animal class, animal animal a2, a2, okay, a2 equal to new of animal. Okay, now I'll create dog d2 equal to, I'll assign it a2 to d2. Now it's giving me the mismatch, cannot convert from animal to dog. Now I'll typecast it to dog. Okay, and see what you have is, now let's try to run it, this one. Okay, we'll comment this part upcasting and downcasting here, uh, for the sake for understanding. Okay, I've commented that part. Now we are left with only this animal a2 equal to new of animal, dog d2 equal to typecasted to dog of a2. Now run this example. So see what happens here is, run as a Java application. So what you got? You got an error. That is basically class cast exception. Okay. So basically the compiler allows it because it is compatible, but JVM checks the actual object at a runtime. So basically Java compiler is allowing because these types are compatible, but the JVM is checking the object, actual object at the runtime. So that is basically very important, you need to know, and that is very um I mean to say very conceptual thing you need to remember. Okay, now that is very uh, critical thing here in typecasting. Now let's move further. So basically, uh, so today you have understood the reference type and actual objects can be different. Okay, upcasting gives you the flexibility, downcasting gives you control. But here's the real twist in Java. Sometimes the reference doesn't matter at all. The method that runs is decided at the runtime. Okay, and that single idea is the backbone of the interviews. Polymorphism and real world coding. If you don't get this, that you will then you will be keep guessing, right? But if you do so, you will start predicting Java's behavior. And that's why exactly what we are going to break the behavior down in the next video. So that is basically we are going to exactly break down the behavior in the next video. So thanks for watching this video. Thanks. If you like this video, subscribe the video so that you will get the latest videos uploaded. Thank you. Thanks.